Right, my name is David Mills. I'm here from Softree, and I'm going to be giving our webinar this week on Softree Optimal. Let's just run through a quick quick PowerPoint here to show you the topics we're going to be covering today. So our optimization software allows you to define an alignment. You usually need some original ground, and it's usually LiDAR if you're working with multiple horizontal alignments, but it could be any kind of surface that represents the ground. You design a horizontal alignment and then pick what your cross-section looks like. You enter a few costs, or take our defaults if you like. And in some cases, you add constraints. And the optimizer will generate an alignment, a vertical alignment, with the property that it has the lowest possible earthwork cost. So there's various kinds of costs you can define. You can define cut and fill costs. You can define movement and loading costs. And there are also costs that can be applied to pits, and so on. The culvert costs are not included in the optimizer, although you can, of course, look at those costs later. Constraints. So you can define your grades for your road and curvature, vertical curvature. You can also put in control points, so you can force the road to go through various locations vertically. And finally, you can also define the flow of material and whether or not you have full bench or a minimum fill. So there's a lot of control to to constraining the alignment. So why would one want to use Softree Optimal? The main reason is that you can save a lot of time in your design, and you can quickly compare different alignments, vertical and horizontal alignments, and you end up with the minimum road cost. Now, these are earthwork costs, so there are other associated costs with the road, but we can minimize the earthwork costs, and it basically reduces your design time. It's going to allow you to iterate through various options quicker than if you didn't have the optimizer. And the output is compatible, the input is compatible, so you can work with other software in conjunction with Softree Optimal. I'm going to do the demonstration of our software. If you have any questions, you are muted, so you can't talk to me, but you can write a question in the questions area in the GoToWebinar panel. I will try and notice them. If I don't answer right away, it's just because I haven't seen the question yet. And we should be done in about half an hour. I'm going to start off with our location module. So here we go. I'm going to use version 9 of our location module. This is where we design roads in RoadEng. And I'm going to start with a brand new alignment. So we need a surface. I've got a nice surface that's defined from some LiDAR data. I won't go on to that. I won't go into creating the surface. So we've defined a surface. Now I'm going to define an alignment. Again, our software is great for designing horizontal alignments and vertical alignments, but I'm just going to open one. So this alignment comes from an XML file. I actually created it myself from a customer's horizontal and my vertical. So we're just skipping over the design for the horizontal alignment and even for the vertical. Cross-section template, I'm going to use the one that I'm getting by default here. So we're really jumping ahead from a normal road design project. You would probably do a little bit of work to create your surface. You do a little bit of work to create your first horizontal alignment, and you do some work to design your vertical. So I've done all that. Now, in our software, whether you have Softree Optimal or not, you can calculate the cost of your alignment. So if I click on this button here, it generates the cost, and you can see the numbers here. So it's saying it's going to be $228,000 to build this road. Those are earthwork costs only. And in addition, again, standard road edge functionality. We've got a dynamic display of the mass haul diagram. We've got some, those are just grades. We've also got some volumes here. And here's all my cross sections. You can see this cross section's in fill. There's probably one here that's in cut. And this is a very simple forest road, access road kind of cross-section template. And I'm not going to do anything fancy with materials. I'm just going to use the default material, OB for the ground, OB for fill. And there we go. We've got a road designed. Now what can I do with the optimization? Oh, I've got a question already. The question is about the costing function. Can it be used for other types of earthworks, like using our grading tool in terrain? And the answer is no. This is just for road edge. Okay, so I'm going to now do an optimization. So I like this alignment. I built it myself. I'm going to make a new alignment using the optimizer. And we'll call this quick curves, because that's what I'm going to do. And I'm going to set k equals 20. Okay, so that's my name. In here we have a few options. These numbers are important. They define the vertical band, the offset from the initial vertical alignment. The initial vertical alignment can be a hand design, or it could just be the ground. So I'm going to use the ground here because often you don't have an initial vertical alignment. So let's pretend we don't. You'll see in a second what the vertical band means, but basically we're allowed to go plus or minus 10 meters from the ground, and it doesn't bother calculating outside of that band. We're going to cut the road up into a bunch of sections, and I'm just going to pick a section every 20 meters. Again, we'll come back to whether or not this kind of sample spacing is reasonable. I've done this before, so I know 20 is good, but basically the sample spacing depends on how bumpy your ground is. If you've got nice smooth ground, you might get away with a longer sample spacing. The sample spacing determines how many points we have to calculate, and that costs you a bit of time later. So, okay. Let's go to the Standards tab. This is where we define what kind of vertical alignment we're going to create. I'm just going to create an alignment with back-to-back curves. They will be 20 meters long, and they will each have a K of 20. My max-min grades are defined here. So that's my first most important constraint. How steep can the road be? My second constraint here is the curvature, the vertical curvature. Notice there's a station range available here. I'm just doing the whole road the same, but you can actually have sections with different constraints for curvature and grade if you want. This looks fine. Let's go on to control points. Now I can add a control point anywhere I like. I'm going to put one at the start of the alignment, and I'll pick up the existing alignment, assuming that I designed it well. This point here is probably connected to an existing road, so I don't want to modify that elevation. It's going to be a fixed control point. In addition, I will reduce the allowed grade to be 0 plus or minus 4%. So we're branching off an existing road. We probably don't want to go off too steep. That's enough for control points for now, although I could add more later if I wanted to. I'm not going to put in any borrow or waste pits. This will force the software to balance the alignment. Here I'm using our default costs. There's a table. You can open this table from your hard drive. And that's the old ground types table. It used to be called GND, and now it's called GDX. It contains all the materials that you can use in the design, in addition a cost for each material. And here's all those costs. So for example, the default material costs $12 to excavate a cubic meter, and it costs $4 to compact a cubic meter. There's also haul costs, and there's it's a pretty sophisticated tool for determining how the software calculates your haul costs. The defaults work pretty good. In summary, the short answer is this allows you to define the dollar cost per cubic meter per kilometer. So you're looking at how much does it cost to pick up a cubic meter of material and move it a kilometer down the road. This will be used to calculate haul costs. Now there are a whole bunch of other constraints which I'm not going to go into now. We don't need to put any of those in. We're going to work with the small set of constraints that I've defined here and let this thing optimize. Now, I wanted to show you the vertical band so it was kind of clear what was going on. Here's the, oops, there. Okay. So those dashed blue lines there are showing me how far from the ground I can go, and I need to fit an alignment inside there. It is possible, if the ground is very bumpy, that your alignment won't fit between the plus 10 and minus 10 meters. Of course, you can change that to be bigger numbers, make the band wider. The other thing you can do is you can put in a hand design and use that as your initial alignment, and then the band will be as smooth as your initial alignment. Right, so I've got a cost now of $228,000. Let's optimize this one. Now at this point, it's calculating every cross-section. Remember I chose 20-meter spacings. It's calculating every cross-section along the alignment, and it's doing it at multiple elevations inside that vertical band. So this takes a little time. Rather than sit here and watch it count down, I'm just going to open another instance of location, and we'll work from now on with a slightly smaller alignment, a 600-meter alignment. Let's just open that. So this alignment is actually a piece of the other one. It's the end piece, and there's the plan, there's the profile. And this alignment here that we're looking at is actually the result of an optimization. So let's recost, because I just reopened. It needs to be costed. There we go. And for this little segment, it's 70,000. You can see the mass haul diagram is balanced. I've got a different screen layout. Our software is great for allowing you to save window positions and options. I'm just going to open one of those screen layouts that I've set up for Softree Optimal. This diagram here we call our OptiHaul graph, and it's showing me how the material is being moved back and forth. If you hover over the graphic, it tells you how much material is being moved. The arrows show you which way it's being moved. The top one is free haul, the middle one is overhaul, and the bottom one, we don't have any, is end haul or long haul. And there's a mass haul diagram at the bottom, and again, you can see it's balanced. Right, so I've got a vertical alignment. Now remember, I chose the option quick or curve, fast, 20 meters. What does that mean? That means that I've actually got, let's turn on curve labels. out a whole bunch of curves, and they're back-to-back curves. So this is kind of squeezing the road down to the lowest cost with the most flexibility, at least with k equals 20. Turn those labels off again. Now our other alignment should have finished by now. There it goes. Okay. And you can see that it's created an alignment. It's virtually balanced, not quite. It's never perfect because the optimizer is working with an approximation of the cross sections. It's not working with actual calculated cross sections. It would take too long. And this is going to cost $190,000. Okay, so back to the short road. Really, we're in the same state with the short road. It's just a little shorter. Now, I've created an alignment without too much work. I would like to see what happens if we change some of these parameters. So I'm going to create a new alignment here. The software allows me to have as many vertical alignments as I want. Let's just change one parameter and see what happens. So I'm going to change the K factor here. Make the curves sharper. And recap my optimization. So this is a relatively short road, doesn't take too long. I'm only doing cross sections every 20 meters. And I can tell that's actually a reasonable spacing, and I'll show you how in a second. There, it's finished the optimization. Now, the pre-process, where it's calculating all those cross sections, in this example is taking way longer than the actual optimization. So preparing for optimization takes longer than doing the optimization. The process time is shown as 0 here. It was less than 1 second for the optimization. So what have I done? I've got a new alignment. You can see it in magenta here, which is sharper curves. So it's below the first alignment here, and it's above the first alignment here. So it's obviously going to have less volumes, and in fact the cost is less too. Cut and fill costs are based on volumes. Let's compare these two. Actually, let's set this one current before I do the comparison. Looks very similar qualitatively. There's less overhaul, more all material movement is free haul. The total material moved, you can see, is kind of less. And the mass haul diagram, I should have actually looked at the numbers there. That's minus 1,000. The other one was much bigger. So yeah, we could look at the table if we wanted to see what kind of volumes we've got. But the summary results are very easy to look at, very quick. These numbers here, total cost and haul volumes. Let's look at the comparison. I've got that turned on already, so I just need to select both. There we go. So the current alignment is the one I just did. That's number 2. It's 44,000 total. And the previous alignment with K equals 20 is 70,000. We got a almost 40% reduction in cost. You would expect that. That's the kind of thing you can do. You can very quickly try a new alignment, change a few parameters, run the optimizer, see what it's going to cost you. Obviously, making K smaller means the road has a smaller design speed. Is that worth the extra $30,000 that we save? Your call. Now, what if we wanted to change the horizontal alignment? That's really, I think, the most powerful thing here. We are working on a horizontal alignment optimizer. It's being tested right now, and if you get our beta version, you can take a look at that. But even without a horizontal alignment optimizer, you can do the optimization yourself, or at least you can compare various horizontal alignments. Now, in version 8 of our software, we do have the ability to have multiple horizontal alignments. You can click on this Add button here and create a new alignment. In version 9, which I'm using right now, it should come out in the fall, there's a Duplicate button. Now, if you didn't have version 9 and you wanted to try a new horizontal alignment, what I would do is I would do File Save As. So I would have 2 location designs on my hard drive, maybe even open at the same time. You can have multiple instances of the location module open. But I'm using version 9, so I'm going to use these, this little trick here. Duplicate my alignment. It's called Horizontal Alignment 2. I could give it a fancier name if I wanted to. And modify it. Let's maximize the plan so I can do this a little better. There's an IP point in there. I'm going to pull it over here. And what I'm going to do is try and track that contour rather than going up over this hill. Now, this originally was a road that was used for a wind farm, and there's a good reason why it's going over that hill. It has to put a windmill up there. But if I was designing this for another reason, just to get from A to B, I might want to go around the hill. This is going to make the road longer. Let's put in a curve there because I don't want to just have a sharp corner. Okay, so I've changed the length of the road, but the profile is a lot smoother. You can see here the ground. I mean, my road used to go up there. My ground is now pretty flat. And basically any change I make to my horizontal alignment, the ground line updates dynamically. So there, I've changed my alignment. I've changed what the ground line looks like. If I were designing by hand, I'd have to go back and redesign the vertical alignment. Using the optimizer, I just push this button again. So let's compare the K equals 20 design. There it is, and that one we need to recalculate it. Let's just recalculate it. I don't need to change anything. Okay. In fact, I don't need this one anymore. I'm going to delete that. Okay, so back to the K equals 20 design, re-optimize it. Now, it's clear that a flatter road should be less expensive, but on the other hand, a longer road might be more expensive. So the results are not obvious. There we go. In a small amount of time, I've got a new result, and the cost is $42,000. Don't need to run the comparison check here. Okay, so $42,000 for my longer road. There's my shorter road. Let's just switch back to it. And that one, there we go, was $70,000. And I can just use the switch here to compare them. The compare function doesn't work between horizontal alignments. We're working on that. So to switch to compare, I literally need to either do a save as, so I can look at both designs side by side, or switch alignments and watch the numbers change here. Well, that covers the idea of changing different both parameters. We tried changing the K factor to see what happened to our costs, and changing the horizontal alignment. We switched between 2 horizontal alignments here. What else can you do with the software? Well, one thing I wanted to show you before I finish, and we're almost done. This alignment was created. Which one are we in now, by the way? Oh yeah, we're in the flat one. So this is horizontal alignment number 2, and if I turn on my labels here, you can see we've got a lot of back-to-back curves, and maybe this is not how I want to design it. So let's see. I am going to create a new, oh, I did create a new alignment. No? Oh. Sorry. Oh, I've lost my license. Oh, let me just get out of here and come back in.
Well, hello again. I'm back after our small technical difficulty, and what I'd like to show you now is how we can take this alignment which has way too many curves in it and generate a new one with tangents and curves. Okay, I already did that before. Let's delete that and start again. Okay, we've got an alignment here. I'm going to duplicate it. It's a new vertical alignment. Let's call it tangents plus curves, and change the properties. So my properties now have standards set to curves fast. We have two other choices for curves. Notice there's also one in here for polyline if you just want to create short segments with no curves. I'm going to use this one, curves and tangents, and set the minimum curve to 40 and the minimum tangent also to 40. The variable curves and tangents just gives you a little more flexibility. Okay, I don't need to change anything else. Let's just run that optimization. So here it is. Take a few seconds to pre-process, as it always does. Oh, just a sec, I've got my pre-process settings wrong. Yeah, I don't want to use all points. I just want to use 20-meter sections. So it's taking a little while to do the pre-process. Now, the optimization will take longer as well. This is because it's a more difficult problem to solve. And wow, that's loud. There we go. Let's take a look at that design. As you can see, there's tangents between the curves. The alignment is slightly different. There's a little difference here. So because I was forcing curves to be longer, forcing tangents between curves, I was constraining the optimizer, and the results are it's slightly more expensive. So the new optimization is 7.5% more expensive than the previous. Now that optimization didn't take long because it was 600-meter road. It's nice and easy for the optimizer to deal with. But if you have longer roads, these curves and tangents and variable curves and tangents do take longer. There's another option here for user-defined, which allows you to pick the curve locations yourself and then have the optimizer raise and lower them and see if it can find a better vertical. Let's look at some of the other options that are available. I mentioned earlier that you can set up your spacing here, but sometimes it's hard to know how far apart you should put your cross sections. And there's actually a tool to help you with that. If I go into Recasts, search for a good spacing for accurate costing. What that does is it tries a whole bunch of different sample spacings and comes up with a number, in this case 5, that will give you a very accurate optimization and recost. In this case, 5 is a lot less than what I was using, so I might be interested to know how accurate was my cost. Well, first of all, I'm doing a balanced alignment, so one of the first things you will notice, even though the optimization is supposed to be balanced, there will be a little bit of overflow, and that overflow or underflow is an indication of approximation in the optimizer. There's also a output item here called confidence level. And 0.3% is very good. So we really are quite happy with this result. So even though the software said use 5 meters, 20 meters worked okay. But if I had picked 100, pretty sure I would get inaccurate results. Yeah, there's that little overflow I was telling you about. Not very much, but a little bit. 150 cubic meters. Okay, again, if you have a complex design, you may want to make the optimizer accommodate the complexities. You can add different materials along your alignment under the ground, subhorizons. You can apply different materials to fill, again, by station range. Those will change the outputs so that you now have multiple materials instead of just the one. The software will still balance all the materials so that if you cut gravel, you must fill it somewhere or put it in a waste pit. Similar with other materials. There's also the ability to add more control points. Typically, if you have a bridge crossing, you might want to have a control point to define the bridge abutments. Similarly, if you have a road crossing, an intersection, you may want to add more control points to force the road to the right elevation so it meets the crossing road. Also with bridge crossings, sometimes you want to take the curvature out for a station range. You can do that. You can set it to be linear for a station range and it will force the road to be flat. And you can change the grades. So for example, crossing a bridge, we might say, okay, the bridge must be between 1% and -1%, and it's flat. And we just put in a station range, let's say 200 to 250, like so. Oops, I did 0 to 250, oops. Anyway, I'm not actually going to test this, so we can go on to the next thing. Pits allow you to define borrow and waste pits at various stations. You can borrow a particular material and you can waste in such a way that any material will go into your pit, or you can even say, no, I want high quality material in my pit. Again, materials have qualities. So when we're using multiple materials, if we specify a particular material must be used in fill here, we can either say get me GR material or nothing, or we can say get me anything better than Q3, quality based, replaceable. So you might be filling in a zone where you need a high quality material, and other materials that have high quality like solid rock or shot rock will work and can be replaced, and that gives the optimizer more flexibility. There's also constraints. For example, you could select a zone, a station range, where you must have fill of at least 1 meter or at least 2 meters. This is particularly useful in muskeg and permafrost. Full bench cut, you can tell the software that you want a no fill for a station range. And you can even generate those station ranges by looking at the side slopes. So for example, anything greater than 40% side slope, there isn't any. Let me try a smaller side slope. Oh. We must have side slopes of 10%. There we go. So this section here is full bench because our side slope has been exceeded. This section here is not full bench because our side slope has not been exceeded. Fairly nice tool. Similarly, you can choose to prevent the software from moving material backwards towards the smaller stations or forwards towards the bigger stations. Actually, you force it to go forwards or force it to go backwards. And again, you can pick the grade at which you expect this to happen. So for example, here we've got a downhill section. So I might say I'm not allowed to move material uphill. So I'm going to go forwards when the grade is greater than 5%. And there we go. So forward in that section, either in those sections, and so on. In addition, the software has two different solvers. CBC is free, comes with the software. It's an open source package. Cplex is made by IBM. It is an optional add-on to the software. Way faster. And but they both give the same, essentially give the same results. Okay, so in our presentation, we showed that the software is very quick to come up with some basic alignments. Doesn't take long to set up the options, doesn't take long to actually calculate for a relatively short alignment. For longer alignments, you're going to be waiting for that pre-process time. It does take time. And in addition, you'll be waiting for the optimizer to finish. So you want to be careful that you don't put in too many cross-section points here. 37 is hardly any at all. If you're getting up around 500 or 1,000, then it's going to take a lot longer. Similarly, you want to use the quick calculations first, polyline curves and curves without tangents, and user-defined. Those go really fast. And then once you've got a solution that works, you might want to try the other ones to introduce tangents and wait for it. We looked at the constraints and the vertical band. It is possible to create an infeasible design by putting in too many constraints or narrowing the band too much. So I recommend that you start with a simple setup with very few constraints, nice wide band, and you might even want to do the feasibility test process, check feasibility, and just make sure it comes out feasible before you start adding more and more constraints. That's all I wanted to say. Thank you for watching our webinar.